Greetings, beautiful people. Welcome back to Find XYZ. If you are new to this channel, kindly subscribe, like, and leave a comment. Let's begin. Now imagine you are standing at one corner of this park. So you are standing right here, and then your friend is also standing in the complete opposite side. How do you get to your friend? Well, you could walk across all the way up to this 10 and then move all the way up to your friend. That works, right? But it takes a very long time to get to your friend. What if you decided to cut straight across the grass? Well, that diagonal path is definitely shorter, but exactly how far is it? We can't just count the blocks as we did on this side. We can just count the blocks and know the distance because we are cutting across them. To figure this out, this diagonal path, we need the distance formula. Let's see how it works. I'll first draw my coordinate plane. Alright, so I'll label this my x-axis and this my y-axis. Now I need two different points, right, on this coordinate plane. So let me draw a line. So I'll label this as point A with x1, y1, and this as point B as x2, y2. Now I'll trace this coordinate to the x-axis, so this will be my x1 and this will be my y1. Then I'll trace this as well to the x-axis, so this will be my x2, and I'll trace this to the y-axis, and this will be my y2. We want to find this diagonal path, right? So let's create a right angle triangle. Great. Now anytime we have a right angle triangle, we can apply what we call Pythagorean Theorem, right? Where we say a squared plus b squared will give us the hypotenuse, that is the longer side. That is the diagonal path that we want to use. By using the Pythagorean Theorem, we say a squared plus b squared is equal to c squared. But what is the length of a? What is the length of this side? So from this point to this point, we can write it as the distance between from this point to this point is x2 minus x1. That will give us the distance of a. And then if you want the distance between these 2 points, it is y2 minus y1. So in place of a, we can substitute s2 minus x1, that is a. Then what is b? y2 minus y1. Then we square it is equal to c squared. Because we are looking for the diagonal path, we are looking for the distance between these 2 points, we can just take the square root of both sides. Then square takes care of the square root, so we have c to be equal to x2 minus x1 all squared plus y2 minus y1 all squared. Now this is how to find the diagonal path, that is the shortest distance. So anytime you have been given 2 points to find the distance, you use this formula. There are so many ways of writing the distance, so sometimes they can ask you to find the magnitude, or they can ask you to find the length. Or let's say they have given you 2 points, let's say a and b. The notation is written this way, so anytime you see this notation, just know you are required to find the distance between these 2 points, or the length. So in today's lesson, we have discovered the formula for finding the distance between 2 points. Let's move ahead to use this formula to solve some examples. In this question, we have been given 2 points, point P and point Q, and we are asked to find the magnitude or the length of PQ. I would always encourage you to write your points and label them. So we have point P, we'll label it as x1, y1, and point Q 47 as x2, y2. Now if we want to find the length of PQ, we need our distance formula, which is x2 minus x1 all squared plus y2 minus y1 all squared. Because we've labeled our points or our coordinates, it will be very simple for us to substitute. So we will look at this. Alright, so we'll do 4 take away 2, we square it, plus 7 take away 3, then we square it. Now what is 4 minus 2? That will give us 2 all squared, plus 7 minus 3, that will give us 4 squared. 2 squared will definitely give us 4, plus 4 squared will give us 16. Then 4 plus 16 will give us root 20. Anytime you are asked to find the distance and you get a set, it is appropriate that you leave your answer in a set, but make sure it is simplified, right? So root 20 can be simplified to root 4, root 5, and then since root 4 is a perfect square, we can get 2 root 5. Then because we don't know the unit we are working in, our final answer should have what we call units. Okay, so the distance between P and Q is 2 root 5 units. Let's try another example. The question is, a straight line passes through the points A and B. We are asked to calculate the length of AB. As I told you earlier, I would encourage you to write your points and label them. So point A, 1, 2, we label it as x1, y1, and point B, 5, 8, we label it as x2, y2. Now the length of AB will do s2 minus x1 all squared plus y2 minus y1 all squared. Then we substitute this into the formula. So what is x2 will be 5 minus 1 all squared plus 8 minus 2 all squared. Now what is 5 minus 1? That will give us 4 squared plus 8 minus 2, that will give us 6 squared. Now 4 squared will give us 16. 6 squared will give us 36. Then 16 plus 36 will give us 52. Can we simplify this? Can we get a perfect square and a prime from 52? Yes. So we have root 4, root 13. Then root 4 will give us 2, root 13. Then because we are asked to find the distance, we add the units to our final answer. So always leave your answer in a simplified form. So that is the distance between A and B. Let's take the last example. We have been given 3 points, point O, point P, and point Q, which are vertices of a triangle OPQ. We are asked to find the type of triangle. Now let's sketch our triangle. This is point O, this is point P, and this is point Q. Point O has coordinate of 0, 0. Point P has coordinate of 4, -1. And point Q has coordinate of 1, -4. How do we identify the type of triangle? Before we can make that decision, we need to know the length of these sides. So we can first find the length of OP, then we can also find the length of OQ, and then we can find the length of PQ. After that, we'll make a decision on the type of triangle. So let's find the length of OP. Point O, 0, 0, and point P, 4, -1. As I've been saying, I will encourage you to label your points. So we have x1, y1, and then x2, y2. Length of OP, we have x2 minus x1 all squared plus y2 minus y1 all squared. We can just substitute in our value. So we have 4 minus 0 all squared plus -1 minus 0 all squared. This simplifies to 4 squared plus -1 squared. So 4 squared will give us 16 plus 1, because every squared number is a positive number. Then 1 plus 16 will give us root 17 units. So that is the length of OP. Now let's decide on the length of OQ. For OQ, you need point O and Q. Point O is 0, 0, and point Q is 1, -4. Now let's label our points. So we have x1, y1, and then x2, y2, which is x2 minus x1 all squared plus y2 minus y1 all squared. Now let's substitute in our points. So we have 1 minus 0 all squared plus -4 minus 0 all squared. So this simplifies to 1 squared plus -4 squared. 1 squared will give us 1, -4 squared will give us 16, because every square number is a positive number. Then this simplifies to root 17 units. Let's work on the distance of the last side, which is PQ. Now for PQ, we need the length of P, which is 4, -1. We need the coordinate of Q, which is 1, -4. Now label your coordinates. So we have x1, y1, and then x2, y2. x2 minus x1 all squared plus y2 minus y1 all squared. Then let's substitute our values. So we have 1 minus 4 all squared plus -4 minus -1 all squared. 1 minus 4 will give us -3 squared plus negative multiplying negative will give us positive. So we have -4 plus 1, that will also give us -3 squared. Every squared number is a positive number, so this will result in 9 plus 9. That will give us root 18. Now root 18 can be simplified to root 9, root 2, then root 9 will give us 3 root 2 units. The length of PQ is 3 root 2. The length of OP is root 17, and the length of OQ is also root 17. Now, can you tell us what type of triangle has two lengths being the same? Realize that the length of OP is root 17 and the length of OQ is also root 17. It means that triangle OPQ has two sides being equal. Now, what type of triangle has two sides being equal? That type of triangle is known as the isosceles triangle. It's an isosceles triangle because two sides of the triangle are equal. Thank you for joining me. If you enjoyed this video, kindly subscribe, like, and leave a comment. See you in the next video.